Hello everyone, today we are going to see the practical of data communication and computer network. The name of the practical is frequency shift keying, that is FSK, using any simulator. For this practical we are going to use the online simulator, that is Google Colab. First of all we have to open new notebook in the Google Colab and start the coding. First we have to import the libraries, that is first of all NumPy, and second one is the matplotlib. NumPy is used for the mathematical operations, and the matplotlib for the graph plotting. In the next line we are going to use the two parameters, that is the first one is the sampling frequency, that is denoted by the Fs. We are going to take Fs equal to 1 lakh sampling base frequency, and second parameter is the bit duration. Bit duration is denoted by the TB. TB equal to 0.001, that is the 1 milli per second. And in next line we have to get the input of binary data, that is data equal to np.array. In that we are going to use 1, 0, 1, 1, 0, 1. We have to use one print statement. In that print statement, input bits, and in that call the data, that is comma data. In next line we are going to use two frequencies. First one is the high frequency for bit 1, that is f1 equal to 15,000, and the low frequency for bit 0, that is f0 equal to 8,000. In next line we have to calculate the time for the each bit, that is the t of bit equal to np.arrange in bracket 0, tb, 1 upon fs. In next line we have to actually start FSK modulation, that is frequency modulation, frequency shift keying modulation. In that FSK signal equal to np.array. We have to call the array. In next line we have to use the for loop. In that for loop, for bit in data, if bit equal to 1, that is frequency for bit 1, then the signal equal to np.sign into np.py into f1 into t of bit. Else means frequency for bit 0, that is signal equal to np.sign 2 into np.py into f0 into t of bit. And next line FSK signal equal to np dot append in bracket FSK signal comma signal. In next line we have to calculate total time for entire signal, that is the formula is t equal to np dot arrange 0 comma length of data into tb comma 1 upon fs in next line we are going to see the plotting. The first line in that plt dot figure size equal to 14,8. In next line we have to plot the input data. For that plt dot subplot 3,1,1 in next line plt dot step in bracket range length of data comma data comma where equal to post. In next line we are going to fix the title, that is plt dot title input binary data in next line the label of y-axis is bit value. For that plt dot y label in bracket bit value in next line we have to plot the grids. For that we are going to use plt dot grid equal to true. In next line we have to plot the individual carrier frequencies. For that first of all plt dot subplot 3,1,2 next line sample plot time we have to take t of 1000. We have to take samples of 1000 clarity for purple. In next line we have to plot these sample points, that is plt dot plot in bracket sample plot time comma np dot sign in bracket 2 into np dot pi into f1 into sample plot time. Comma label equal to F1 for bit 1. In next line, we have to as it is copy and change for the frequency, that is F1 to F0. And F0 for bit 0. In next line, plt.title carrier frequencies for bit 0 and bit 1. For bit 0 and bit 1, we have to set the y label is the amplitude. For that, plt.y label in bracket amplitude, and in the next line plt.legend and plt.grid in bracket true. In next line, we have to plot the FSK modulated signal. For that, we have to subplot the plt.subplot 3, 1, 3. Next line, plt.plot t, FSK signal. In next line, we have to decide the title. For that, plt.title FSK modulated signal. For x-axis, we have to decide the time, and y-axis, we have to decide the amplitude. For that, plt.x label in bracket time of s and plt.y label we have to take the amplitude. In next line, we have to take the grid. For that, plt.grid in bracket true, plt.tight layout and the plt.show. In next, run the code and see the outputs. See the output for the input data 101101, for the input binary data, carrier frequencies for bit 0 and bit 1, and the FSK modulated signals.